Right, in this little tricky moments question here, what we're going to do is we're going to start off and we're going to try and find, in terms of W, the magnitude of the reaction of the rod at its point of contact with the cylinder just here. So what we need to realise is when you have a point in contact with a cylinder, we've got a tangent on a radius. So the normal reaction will be at right angles to that point of contact, because the point of contact is a tangent against the radius. And the length of this is going to be 5b. We're going to have the weight acting straight down. Okay, and we're basically going to take moments about A. So let's just take moments about A. Let's do it that way. So we're going to have R times 16, not 16b actually, because we know this radius is going to be 5b and that's going to be 13b. Now what you should realise is what we have here is a 5, 13, 12 triangle going on here. So therefore this distance here will actually be 12b. So we're going to have R times 12b will be the clockwise moment, and then we're going to have a bit of W. We're going to, if we call this angle here, and let's call that one theta for example, then this one here is going to be theta, and therefore we're going to have this side and this side, and we're going to have cos theta lots of the weight acting perpendicular to the distance here. So cos theta times by the weight. Cos theta in this case will be 12 over 13. So we've got minus 12 over 13 times by W. Okay, and we've also got to times it by the distance along here, which is going to be 8b. And that must equal 0. So therefore we've got 12b lots of R will equal 12 times 8 over 13 lots of W. Sorry, don't forget my B. Cancel out your B's. Cancel out your 12s, and you'll see that R equals 8 over 13 W. Now that was the easy part of the question. The trickier part of the question is to find the resultant force acting along the rod. So basically the resultant force acting along the rod, okay, at A is inclined to the vertical, alpha equals tan alpha. So basically we're going to be looking at the resultant force from the pivot here acting along the rod. And what we do is we just take two components, is the clever way to do this. We'll have the X component and have the Y component, and then work out what those are. And from those we can work out what the resultant force acting along the rod will be on the pivot. Okay, so if we resolve vertically, we're going to have Y plus the vertical component of R coming from here. So the vertical component of R is going to be R. Now if that's theta, that's going to be theta as well. Okay, there's 90 minus theta, so therefore the angle between this and the vertical is going to be theta. So therefore that we're going to have the vertical component of R is going to be cos theta lots of R. So we've got Y plus R cos of theta, and cos of theta in this case was 12 over 13. And that will be equal to all the forces going down, which is just going to be W. We resolve horizontally. Okay, we got X will equal the horizontal component of R here, which is going to be the sine theta lots of R. And sine theta lots of R is going to be 5 over 13 lots of R. Now, we just bring this across a bit. So what we got here is we've got Y. Now, R we know is equal to 8 over 13 W. So we're going to have W minus 12 over 13 times 8 over 13 lots of W. So we're going to get W taken out, and we're going to get 1 minus 96, sorry. 8 times 12 is 96 over 169 lots of W. And we got R here again. X will equal, R is going to be 8 over 13W, so you've got 5 times 8 over 13W. Now, there's our X component, there's our Y component. Actually, alpha is equal to the vertical, so therefore tan of alpha will equal our X over Y. So tan alpha will equal X over Y. So tan alpha will equal, well, we've got 1 minus 96 over 69, so that's going to give me 73 lots. Oh, so I'm going to do it the right way around. Let's do the X first. Apologies. So my X bit is going to be 40. Sorry, I've made a mistake here. So I've got 5 over 13 times by 8 over 13, so that should be over 169 as well back here. So this should be over 169. Sorry about that. So I got 40 over 169 here. Times by W, divided by, now this is going to be 73 over 169 W. So therefore, the W's will cancel because we're dividing. The 169s will cancel because we're dividing. So we're just left with 40 over 73, which is what we're asked to prove in the question. So go back to the question. See, tan alpha equals 40 over 73. So the key trick was to work out this resultant in terms of, let's work out the horizontal component of it and the vertical component of it. Otherwise, trying to gauge where the resultant force actually acts on this hinge is really quite tricky because you don't know what direction it's starting in. So what we do is we work out the X component, work out the Y component, and if you want to work out the resultant force, then you can obviously square them and add them together to work out the total component.